Hi, my name is Ian Wells, and I'm an undergraduate researcher at Washington State University. Today, I'll be presenting the use of liquid nitrogen to remove lunar regolith simulant from Spacesuit Simulant. On the Apollo missions, lunar dust was found to be abrasive, toxic, and insulating, making it a hazard to astronaut health and equipment. With this in mind, NASA has sought dust mitigation strategies. We believe that liquid nitrogen is an effective tool to remove lunar dust from spacesuits. Today, I'll discuss the background, methodology, and results of testing so far. Starting with background. Traditional methods of dust mitigation are ineffective with lunar dust. Brushing and vacuuming, in addition to being ineffective, are harmful to suit material, causing abrasion and seal malfunctions. Non-cryogenic liquids and gases have also been tested, but have found to be simply ineffective. Liquid nitrogen appears to be effective, and we believe this is due to the Leidenfrost effect. The Leidenfrost effect is where a liquid is far enough above its boiling point, and evaporating gas around the liquid begins to insulate it. This tends to form droplets, as shown in Figure 3, which in our case pick up dust and transport it to the lowest point on a surface. Moving on to methodology. To mimic spacesuit material, we have used a Kevlar weave, which we have verified against PBI orthofabric. To mimic lunar dust, we have used Mount St. Helens ash, which we have verified against near Highland simulant from off-planet research. To apply liquid nitrogen, we have used a Brimil cryogun loaded with liquid nitrogen. The variables that we tested are angle, distance, and time of application, as well as cleaning method. For our analysis, we have done a mass percent removal and a confidence interval on the mean mass percent removal. So for our results, the optimum cleaning tool was a liquid nitrogen spray from the Brimil cryogun. The optimum angle of cleaning was 105 degrees. The optimum distance of cleaning was 400 millimeters. The optimum time of cleaning was 20 to 40 seconds. So, in conclusion, our hypothesis is upheld. Liquid nitrogen appears to be an effective tool for lunar dust mitigation on spacesuits. Based on the amount removed shown in our table, we are able to conclude that approximately 90% of particles below 10 microns are being removed with the cryogun. Extrapolating from the amount of liquid nitrogen used per test with the cryogun, approximately 2 kilograms of liquid nitrogen are needed for a full clean of a spacesuit, which is significantly less than what is needed to pressurize an airlock with the same dimensions as the Joint Quest airlock on the ISS. Future testing is going to focus on nozzles, atmospheric conditions, specifically pressure, and then building a small-scale prototype of what we could use to implement liquid nitrogen in an airlock. So in conclusion, liquid nitrogen is an effective tool. Thank you. Are there any questions?